Today we're going to be looking at exponential growth and decay. So when we were looking at exponential functions, we had the equation y equals a times b to the x. And we would get a graph that looks like this. So this first graph here, this is a growth. And it's growth because if you think of it, it is increasing. So if you're looking at a formula, if b is larger than 1, so your rate here, your ratio is larger than 1, then it is a growth. Now, this graph here is decreasing. So it is a decay. And if you're looking at your formula, b will be a decimal or a fraction that the value is between 0 and 1. So it cannot be larger than 1 or a negative number. So let's look at exponential growth. So when population increases and a growth of monetary investments, then that is an exponential growth. And we're using this equation. Y equals A times 1 plus R raised to the T. Y, that is your final amount. A is your initial amount, so what you're starting with. Your R is the rate of change as a decimal, and T is time. So this is a growth, so it's going to increase. Now, population decreases, and car or investment depreciations. These are examples of an exponential decay. So it's the same formula, but inside the parenthesis, we're going to do 1 minus the rate. Instead of the growth, we're doing 1 plus the rate. So let's look at some examples here. The population of the United States has been increasing at an average rate of 0.91%. If the population was 303,145,000 in 2008, predict the population in 2020. So we need to know what our A is. Our A is our initial amount. So 303,145,000. Our rate is our percent, which is 0.91%, but we have to change that to a decimal. That's 0.0091. And our time. Time is always in years. So we have two time values here, 2020 and 2008. We need to know how many years that is. So we're going to subtract. So when we subtract 2020 from 2008, there is a 12-year difference there. So our time is 12 years. So is this a growth or a decay? We are given that it is increasing, so it's going to be a growth equation. So we're going to use y equals a times 1 plus r raised to the t. Now substitute our values in. Substitute your a in. Then we have 1 plus our r. And our r is 0.0091 raised to the t, which is 12. Now simplify inside your parentheses. It's your decimal plus 1. So we get 1 plus, or 1.0091 raised to the 12th. And don't forget your A. So 3,003,145,000. Now in your calculator, you are going to type this as it is. So $303,145,000 times, do it in parentheses, 1.0091 raised to the 12th. When you put that in your calculator, you are going to get 337,956,562.1. Now, we are talking about population. Population is people. So we can't have 0.1 of a person, so we need a round. And we are going to round down. So there is about 337,956,562 people. So that is our answer there. Now let's look at the next example. Nathan bought a very fancy boat for about $125,000. If the boat's value depreciates at a rate of 15% per year, what's the value of the boat at the end of 10 years? So here we see the word depreciates. So that's going to be our decay. So let's start with our initial amount, which is $125,000. Our rate is 15%. Change it to a decimal, move it over 2 places to the left, 0.15, and our time is 10 years. So we're using the decay equation. So y equals a times 1 minus r raised to the t. Substitute our values in. A is 125,000 times 1 minus our rate, 0.15, raised to the t, which is 10. Now, 1 minus 0.15 is 0.85. Bring down everything else. Now we're going to type this into our calculator. So when you type into your calculator, you are going to get 2,400. Let's try that again. We get $24,609.30. Okay, let's look at the last example here. Olivia buys a new car that costs $32,000. The value of the car is expected to depreciate 8% each year. Find the value of the car in 6 years. So it depreciates means a decay. So our initial amount is $32,000. Our rate is 8%. So change 8% to a decimal, move it over 2 places to the left, and we get 0.08. And our time is 6 years. So again, depreciation, we're going to use the decay equation. Y equals a times 1 minus r raised to the t. Substitute it all in. Our a is 32,000. 1 minus our rate, so 0.08, raised to the 6th power for time. 1 minus 0.08 is 0.92. Rewrite everything else. And now, using your calculator, you want to type this in. And you should get $19,403.36. So let's analyze this real quick. The car, you bought it new for $32,000. And then in 6 years, it's only worth about $19,000. So if you didn't know this, cars depreciate in value as soon as you walk off the lot, or technically drive off the lot. So now the last part of growth and decay is talking about compound interest. So to determine the final amount of money that is invested, you are going to use a compound interest equation. So this is y equals p. P is the same thing that we were using as A in our previous formula. It's our initial amount. So y equals p times 1 plus our rate r, which we've been using. But we are going to divide our r by n. And n is the number of times it's compounded each year. So annually is 1, semi-annually 2, quarterly is 4, monthly would be 12, and daily would be 365. Then your exponent is going to be your n, what it's compounded each time, times the time, so number of years. So let's look at some examples. So when you determine the value of an investment of $2,500 if it's invested at an interest rate of 5.25% compounded monthly for 4 years. So let's just figure out what each of our values are for our variables. So our P, that's our initial amount, $2,500. Our rate, 5.25%. But change that to a decimal. So that's point. Move it 2 places to the left. 0, 0, 5, 2, 5. 2 places. N, how many times it's compounded. So look at compounded, and it's going to tell you. Here we have monthly. And think of how many months are in a year. There's 12 months. So our N is 12. And lastly, time is our number of years, which is 4. So using our compound interest formula, substitute in our values. So our initial amount times 1 plus our rate, 0.052, divided by n, which is 12, raised to the 12, which is n, times years, which is 4. Now let's simplify. Divide 0.0525 divided by 12. That gives us 0.004375. If we're adding 1 to it, just put 1 in front of it. Now simplify. 12 times 4. 12 times 4 is 48. So our exponent is going to be 48, and bring down our principal, our initial amount. So now we can type this into our calculator. Type in 2,500 times 1.004375 raised to the 48. And when you type that in, you will get $3,082.78. So you put in $2,500 and you ended up with $3,082. So that's nice. It's more money than what you started off with. Let's look at the last problem here. Determine the value of investment of 100 should be 1,000. Add another 0. $100,000 if it's invested at an interest rate of 6%, compounded quarterly for 12 years. So our initial amount, 100,000. Our rate, 6%. Change it to a decimal, 0.06. N, how many times it's compounded. So here we have quarterly, And think of how many quarters are in a dollar. So 4. So there's 4 quarters in a year. And the number of years would be 12. Now using the same compounded interest formula, substitute it in. 100,000 times 1 plus our rate, 0.06. Divide it by n, which is 4. Raise it to the n, which is 4, times 12. Now divide 0.06 divided by 4, 0.015. Add 1 to it, so it becomes 1.015. 4 times 12 is 48. Bring down 100,000. Now calculate this in your calculator, and you will get $204,347.83. So that is your lesson today. Please reach out if you end up having any questions.